For this video, we will tackle about insertion sort. So, what is insertion sort? Insertion sort, it is a sorting algorithm in which the values are transferred into the right position. These are split in sorted sublist and unsorted sublist. Compare the variable if sorted is greater than the other value, then shift into other variable until the whole list is sorted. In short, we need to arrange the number by comparing the key to the sorted element. How were to apply insertion sort? Compare the element if it's less than the sorted element, then swap. Place every unsorted element at its correct position and repeat it until you get the arrangement of insertion sort. Basically, kailangan natin i-compare yung unsorted value sa mga sorted values. If mas maliit yung key value kaysa sa sorted value, kailangan natin i-insert yung unsorted value sa sorted part para makuha yung tamang arrangement ng mga unsorted elements. This is the step-by-step procedure kung paano gawin ang insertion sort. Step 1. The first element, assume that it is already sorted into second element. Step 2. Move the next element, which is the key. Now, compare the key with all elements in the sorted array. Step 4. If the element in the sorted array is smaller than the current element, then move to the next element. Else, shift either elements in the array towards the right. Step 5. Insert the value at the correct position, and step 6. Repeat it until the array is sorted. So automatically, yung first at second value is magsuswap. After ng swapping, hahanapin naman natin yung right position ni key. Then, i-compare ang key element sa mga sorted array. Then, pag mas malaki ang key element kesa sa kinompare natin sorted element, proceed tayo sa next element. Then, i-compare ulit si key sa next sorted element. If mas maliit na yung key kesa sa sorted element na kailangan natin i-compare, yung key and sorted element will swap. Then, yung sorted element na i-compare natin will move pa right. Then, ulitin lang hanggang sa mabuo ang arrangement array. So, this is a sample kung paano gawin ang insertion sort. Our sample array, which is 5, 3, 4, 2, and 1, is divided into sorted sublist and unsorted sublist. The sorted sublist is the first value of the array, and the rest are the unsorted sublist. Yung sorted sublist is kung saan tayo mag-arrange ng mga unsorted elements. And yung unsorted sublist naman is yung hahanapin natin sa right position sa sorted area. Sa taas ng array, meron tayong makikita na index, which is yung 0, 1, 2, 3, tsaka 4. And yung array, yun yung mga elements natin. And we have this sample kung paano mag-insert ng key element sa sorted part. If key less than to sorted element, yung 3 at saka 5 is magsuswap. So, yung 3 may insert dun sa index 0. And yung 5 mag-move ng pa-right, which is the index 1. So, this is the result of the sorted elements. And this is how it works. Sa first part ng pagsaswap, kailangan i-compare si key sa sorted element. If it's true na mas maliit si key kaysa sa sorted element, then magsaswap sila. So, 3 less than to 5 is true. Then yung 3 mag-move sa index 1, and yung 5 mag-move sa index 2. And ito na yung sorted part. So, proceed tayo sa next key, which is 4. compare lang natin sa mga sorted element. 4 less than to 3 is false. Proceed tayo sa next element. 4 less than to 5 is true. So 4 will be insert sa index 0 and 3 will be insert sa index 1. And yung 5 will be moved ng pa-right. So 3, 4, and 5 is in the right position. So proceed tayo sa next key, which is 2. Compare ulit natin sa mga sorted element. 2 less than to 3 is true. So 2 will be insert to index 0. 3 will be moved into index 1. Yung key, i-compare lang natin sa mga sorted element. So 2 less than 2, index 0 is true. So 2 will be insert into index 0. 3 will be moved into index 1. 4 will be moved into index 2. And 5 will be moved into index 3. So this is the result of our index element. Proceed tayo sa next key, na kung saan ito na mabubuo yung arrangement ng numbers natin. So 1, compare ulit natin sa sorted elements. 1 less than to 2 is true. So 1 will be inserted into index 0. Then 2 will move into index 1 kasama ng mga sorted elements. So ito na yung result ng arrangement natin. And nagkasunod-sunod na sila, which is 1, 2, 3, 4, and 5. Our time complexity in best case is O of n. Because if the input array is already in sorted order, insertion sort compares O of n elements and perform the swap. The time complexity of best case is O of n kasi isang beses ka lang naman mag-compare kasi nakasort na siya. And yung time complexity natin sa worst case is O of n squared because it occurs when the array elements are required to be sorted in reverse order. That means, suppose you have to sort the array elements in ascending order, but its elements are descending order. The time complexity of worst case is O of n squared kasi you need to sort the unsorted elements. And our time complexity in average case is O of n squared because it occurs when the array elements are in jumbled order that is not properly ascending and not properly descending. The average case and worst case will be the same kasi kinukuha lang naman natin yung highest term of time complexity, which is yung O of n squared. So that is the result of our time complexity. And this is the end of our reporting. Thank you for watching.